Okay. So for number one, it gave me at 0900, I have the following bearings. It gave me the following bearings in per standard compass. So based off the deviation and variation, I converted these all to true. And then after I did that, I simply took the bearings from each of these locations, and I got a starting position right here at 0900. So that was number one. All right, so course steered and how you determined it for the second explanation was, so the question was asking, what is your course to steer if you were required to stay 1 nautical mile to the south of the R8A buoy? So I found the R8A buoy, which is right here. And what I did was I made a mark, a little hash mark right here, which is 1 nautical mile south. And I did that using my triangles, obviously, to measure that distance. So what I did was, this. So here I had my 0900 starting position. I lined up my triangle to where it would be accurately and straightly. I lined it up so it would be accurate and straight on my 0900 position. And at this position, which was 1 nautical mile south of this R8A buoy, I simply drew the line from here through here, and that was my track line. And I determined that to be 268.5 degrees true. So that's number two. So explain how you got your running fix for number 5. So for that, what I did was, so from the Saybrook breakwater light, it gave me 2 different bearings. It gave me my 0913 bearing to be at 312 degrees true. And it gave me my 920 bearing to be at 331 degrees true. So here, this line right here is my 913, and this line here is my 920. So simply what I did was I took my triangle and I placed it on this 913 bearing, and using the second triangle so it would stay in the same position, I slid it up to this 920 bearing, and I drew the line, and it intersected right here at 0920. And that was my running fix for 0920, because I slid with my triangles from here up to here, and then where they intersected was right here. That's how I knew I got my running fix. Okay, so for number 7, the position explanation, at 0935, Cornfield Point is 3.8 miles, and Mulford Point is bearing 116 degrees, at 5.4 nautical miles. What's my 935 position? So what I did was, okay, so let me see. So right here is my 935 fixed position, and how I did that was, I found Cornfield Point, which was, where's Cornfield Point? Okay, so Cornfield Point, I'm just trying to locate that. All right, here we go. So here's Cornfield Point right up here. So it said that 3.8 nautical miles. So what I did was I measured out 3.8 nautical miles on my divider, and I swung it out over here. And where that little arc is, right here, that's how I knew that was 3.8 nautical miles. And then it also saying that Mulford Point is bearing 116 at 5.4 miles. So I found Mulford Point, which was over here is Mulford Point. I drew a track line out of 116 degrees, and then I measured out 5.4 nautical miles with the dividers, and it intersected right here to make that my 935 fixed position. So again, at Mulford Point, I drew my bearing of 116 degrees true, which is what I was told. Ended up right here. And I also measured that out to be 5.4 nautical miles. So that was number 7. All right, so visibility determination of Horton Point, number 12. So what I did was, for that, okay, so what I did for that was, I found out the height of the object, the height of the light which was Horton Point Light at 103 feet. My height of eye was given to me at 20 feet. What I simply did was I found the geographic ranges for both of these values, and I found them to be 16.9 nautical miles. From there, I went on to the luminous range diagram in the blue pages of the Lightless book, and I found my luminous range to be 8 nautical miles, and my nominal range was 14 miles. Obviously, the computed visibility is the lesser of the two, so it's going to be 8 nautical miles in this case. So from there, what I did was, I knew it was 8 nautical miles. So what I did was, I went to Horton Point, which is right here. Here's Horton Point. What I did was I swung 8 nautical miles out from here, and it ended up right here at this position, right here at this position. And then what I did was, I did a 60D street calculation to determine the distance from here to here. I found that that distance was 2.3 nautical miles. I divided it by my speed of 12 knots and got a time of 11 and a half minutes, which I added on to 10:20 to make my time 10:31. So that was number 12. Okay. Sudden drift explanation, number 14. So what I did was this. I used 60D street to figure out where my 1050 DR was on my track line, which is right here. And then using the latitude and longitude it gave me, I got a fixed position of 1050 right here. So what I did was I used my dividers to measure out the distance between these two. And what I determined from that was that distance was very small, 0.7 miles. I plugged that into 60D street to figure out my drift, which is in knots, or my speed rather, is what I was solving for. And what I did for my set was I took my triangle and I set it on these 2 points right here, and then I slid it over to this meridian right here, and I determined that my set was 003 degrees. So in other words, I was set at 003 degrees at 1.4 miles. All right, so gyro error for number 18. What I did for that was, all right, so for number 18, I knew that my heading per gyro compass was 336 degrees. So what I did was I went over to the entrance to the New Haven Channel, which is right here. I put my triangle dead in the middle of this channel right here, the entrance of the channel, and then I slid it over to the nearest meridian, which is right here. And when I did that, I found that my true bearing was 333 degrees. So it was asking me for what is my gyro error. Well, if I know that my gyro heading is 336 and my true is 333, if gyro is best, error is west. So my error is 3 degrees west. And that's all the explanations required.